We're going to use the graph of y equals 3 to the x and transformations to sketch the exponential function f of x equals negative 3 to the x plus 1. Determine the domain and range, the y-intercepts, as well as the horizontal asymptotes. We're going to start off with coordinates of 3 points on the graph of y equals 3 to the x. These are the 3 coordinates that are on the graph of 3 to the x. We can verify that. For the x values of negative 1, 0, and 1, if we substitute those into 3 to the x, we get 3 to the negative 1. Negative 1 in the exponent means reciprocal, so we get 1/3. 3 to the 0 is 1. 3 to the 1 is 3. So that gives us 3 ordered pairs that are on the graph of 3 to the x. We want to use transformations to find where those ordered pairs transform to on the graph of f of x equals negative 3 to the x plus 1. Our base function is y equals 3 to the x, as we were studying a moment ago, and then we have some transformations. The transformations are the negative and the plus 1. Multiplying by a negative is a reflection. And because that negative is on the outside of the function, it's a vertical reflection. The plus 1 is a shift. And because that plus 1 is inside the exponent, that's going to be a horizontal shift. Horizontal shifts are either left or right, and because this has a plus, we're going to shift to the left 1 unit. So what we want to do is perform these transformations on each one of these ordered pairs. It's really helpful if you use the graph to follow along with how we adjust these coordinates. So if we start with the first one, negative 1 and the third. And we want to start by doing the transformation of shifting to the left 1 unit. If we move that ordered pair to the left 1 unit, think about what's happening to the x-coordinate and to the y-coordinate. The y-coordinate didn't change, but the x-coordinate moved to the left, and so that's subtracting 1. So that new coordinate became negative 2 and 1/3. Then we're going to do the transformation of reflection. This is a vertical reflection, meaning that anything that is above the x-axis gets reflected below. So that point, let me highlight that point, right now is 1/3 above the x-axis, and when we reflect it, it will be 1/3 below. So that point has the x-coordinate staying the same, but the y-coordinate changing. So that new coordinate becomes negative 2 and negative 1/3. We're going to do the same idea on the other coordinates as well. I'm going to erase the beginning position and the middle position and just leave the end. For the next point, we start at 0, 1. The first transformation shifts to the left 1. The x-coordinate changed to be negative 1. Taking the original coordinate and subtracting 1 gives me negative 1. The y-coordinate stays the same. Then you're going to do the reflection. So this point is 1 above the x-axis, and we're going to mirror to become 1 below the x-axis. So that ordered pair becomes negative 1, 1. I'm going to get rid of the original and the secondary position. And let's try the next ordered pair. The next ordered pair is 1, 3. I'm going to start with the first transformation of shifting to the left 1. And we take that original x coordinate and subtract 1 to become 0. The y coordinate didn't change. Then I'm going to do the reflection. So right now this point is 3 above the x-axis. We're going to mirror to become 3 below the x-axis. And that gets me to a new ordered pair of 0, negative 3. So continuing with the other parts of this question, we want to find the domain and range, which we'll do in a moment, the Y-intercept, as well as the horizontal asymptote. So let's start with the horizontal asymptote. The base function of y equals 3 to the x has a horizontal asymptote that is right on top of the x-axis. It's the line y equals 0. So I want us to imagine doing these transformations of shifting left 1 and reflecting on this horizontal asymptote. If you take a horizontal line and you try to move that horizontal line to the left, it will still be the same horizontal line because that line goes on forever in both directions. So the transformation of shifting left 1 unit doesn't affect that horizontal asymptote. The other transformation of vertical reflection is also not going to affect that horizontal asymptote, because a reflection is going to take what's above the axis and mirror it to below, and what's below and mirror it to above. So since the horizontal asymptote y equals 0 is right on top of the axis, it's going to stay in the middle and not change. So for this example, the horizontal asymptote will still be on top of the x-axis, and the horizontal asymptote is y equals 0. I'm going to sketch a graph. These 3 points that we adjusted are going to connect to each other, and we know that on this end the graph will get closer and closer to that horizontal asymptote, and on this end the y will go to negative infinity, because that's typically how exponential functions graph. You have one end that's approaching the asymptote and the other end that's going off to infinity. This one happens to be the mirror, and so the y goes to negative infinity instead of positive infinity. So then we can talk about the domain and range. We hold our ruler vertically and go from left to right. You can see that this ruler would start hitting the graph at negative infinity and continue hitting the graph all the way to positive infinity. So the domain is negative infinity to infinity. For the range, we're going to hold our ruler horizontally and go from bottom to top. The first time you hit the graph would be at negative infinity, and you're going to continue to hit the graph until you get to the x-axis. That's where that horizontal asymptote is. You're going to have a range from negative infinity to 0. And since you never reach the horizontal asymptote, we don't put a bracket on 0. We never reach that value of 0. Then finally, we're going to find our y-intercept. So we have the function f of x equals negative 3 to the x plus 1. To find a y-intercept, you let x equal 0. That's f of 0 equals negative 3 times 0 plus 1. That's negative 3 to the first power, which is negative 3. So we have a y-intercept of 0, negative 3, which we saw on the graph at this point as well. On this question, we want to solve the exponential equation using the method of relating the bases by first writing the equation in the form b to the u equals b to the v. So we want to start by writing the equation in this format, and what that means is that on the left-hand side of the equation, we want the same base as the right-hand side of the equation. Our equation is square root of 2 equals 4 to the x. We have square root of 2 equals 4 to the x. So as I look at these two numbers, on the left we have a base of 2, on the right we have a base of 4. We want to have the same base, and I know that 4 can be written as 2 squared. So I would write 4 as 2 squared. I would still need that x. I would carry down that x. And I have to remember that when you have radicals, that's the same thing as the one fractional power. So for this example, because it's a square root, it will be 2 to the 1/2 power. 2 to the 1/2 power is the same thing as square root of 2. Now I'm almost there to write the equation in this format. I just need to do a little simplifying. And on the right-hand side, I'm going to use a property of exponents called the power rule. And the power rule goes like this. If you have a base to a power, and then that whole thing raised to a power, the way we simplify is to multiply the powers together. So that would give m times n. So on ours, we have 2 squared, and then all of that raised to the x power. That would be 2 to the 2x. On the other side, I have 2 to the 1/2 power. So now I've written the equation in this format where the bases are the same on both sides. And I'm going to use the method of relating the bases. Sometimes it's also called the one-to-one property. And with that, what the relating the bases or one-to-one property says is that when you have an equation where the bases are equal to each other, then the exponents must be equal to each other. So I'm able to simplify this equation to say that 1/2 is equal to 2x. And now that I have a simpler equation, I can solve for x, and I'll multiply by the reciprocal. The reciprocal of 2 over 1 is 1 over 2. So on the left I get 1/4, and on the right I get those 2's canceling, and I get x equals 1/4. So that is the solution to this equation, x equals 1/4. Thank you for checking out my videos. Have a great day.